Work from here. Work from there. Introducing Work from Everywhere, a Scalefocus initiative. Designed for these turbulent times where your flexibility is the ultimate benefit. Work from Everywhere gives you just that, the complete work-life balance, unlocking your full potential and productivity along the way. So, where is everywhere? It can be from our modern offices, the comfort of your own home, or another remote location. Nice, huh? You are about to collaborate and connect with your co-workers from a Scale office? No problemo. We have an app for that. No, seriously, we have a real app for that. You can book a desk through our office space system. It lets you easily choose the office location, the working desk, the day, and exact hours. Also, you can park free of charge in every office location. Neat, right? If some days you feel more like a no pants, no problems type of day, we've got you, covered. That means supporting your productivity and working standards at your home, summer villa, or the place you feel most comfortable working from. In order to sustain this, we will be providing working desks, chairs, monitors, and Wi-Fi dongles. If you do need some of these, just let us know. And from there, you are all set for Rise and Teams morning. Quick reminder, your dog will love Work from Everywhere. That's a promise. But let's pause for a second and be clear about it. As good as this benefit is, Scalefocus lives for a work culture that involves live interactions, companionship, and time well spent between colleagues. In order to sustain this, it's beneficial to spend time together as much as we want to.
And now we are back to our virtual studio today with Krasimir Kostadinov, Chief Technology Officer in Scalefocus. We're going to talk about future of IT. So it's a really interesting topic with a lot of trends. Maybe you'll tell us more about.
Yeah. So it's, as you said, it's a quite broad topic. We can have quite a few aspects of what is the meaning of future of IT. It can, we can approach it technology-wise, or we can approach it people-wise. We can approach it in a plethora of ways. But I think it's the most important aspect of it all is people and how it will evolve, because after all, everything is made by people, for people, and so on. So the people aspect of the future of IT is ruled by a number of trends. And first I'll briefly present my company, and I'll use some visuals and so on. So we are an entirely Bulgarian company, started in 2012. Back then, the term startup wasn't yet as popular as it is today, but we are truly a Bulgarian startup. Right now we are almost 800 people in 5 delivery locations. We have a number of offices throughout Europe, also in North America, which are basically sales offices and so on. That's the growth of the company. Our primary markets are North America and EMEA, and we are specializing in a number of industries. So we are software engineering and consultancy company. That's quite an ugly slide because it has too much information, but that's our main focuses in terms of technology, and we are a partner of the big technology vendors out there. We have a number of awards, but back to the topic. So as you know, there are a lot of ways to predict the future. One is looking through crystal balls, using tarot cards, whatever, which is dubious at best. But the other approach is what Ray Kurzweil defined in his actually in a number of works, but the first of which was intelligent machines. Basically, follow the trends and extrapolate what those trends mean. In 10 years' time, you can predict what a particular trend with a high degree of certainty will lead to. So the future of IT first is ruled by this graph right here, which is the number of information that we have as humanity. So as you can see, it's not linear. The quantity of information grows exponentially. Basically, every 5 years, so from 2015 to 2020, the information produced was more than the whole previous history of the humanity. The same holds true for 2010 to 2015 and so on and so forth. That trend is always accelerating. COVID unfortunately had the one of the many things that it changed is actually it made the grade steeper, because more people are holding online meetings, more content is digitized, streaming services are quite popular in terms of entertainment and so on. So
in our memories, everything is in social medias, and we turn to Homo digitalis from Homo sapiens, actually.
So the other interesting thing is the Metcalfe's law. So Metcalfe is a scientist that used that law to predict the value of telephone networks back in the day when they were consolidating in the United States. So the idea is, when you have, as this thing shows us, more information, it becomes not, if you have twice the information, it's not twice as valuable. It's exponentially more valuable because the amount of things you can do with that information, innovation, whatever you want to do, grows exponentially. It's not just double the possibilities. So you can imagine this growth, regardless, the amount of information grows exponentially, and also what we can do with that gathered information grows exponentially more. So those are the two main trends that I believe IT is here to stay, and not only here to stay, but the demand for IT will grow exponentially, basically. And the other trend is digitalization has a weird self-catalytic effect. Basically, when you digitize something, there is pressure on all external systems that are non-digital, or businesses, or supply chain links, whatever, where the parts of the system that are not digitized are under a lot of pressure to be digitized as well, to interact with the rest of the system better. So the more things you have digitized, the more the pressure on the non-digitized businesses to digitize. So those trends together basically lead to the exponential growth of demand for IT services. The problem is that people do not grow exponentially, and especially trained engineers. The last statistic that I managed to find for 2020 was about 56 million people worldwide, and that's according to Statista.com. That's IT and telecommunication companies. It's not IT, just IT, but both sectors measured roughly about 56 million people, and they grow about 2.2 million people year by year. So the growth is not exponential in the number of people. So what this leads to is basically you have more work to be done by exponentially more work and linearly more people.
So maybe this will lead to more automation, of course, and
yes,
some change also in workforces.
Yes, so there are a number of ways to resolve that conundrum. So on one hand, you have less people to do more work with. One of the obvious approaches is automate as much as you can. The other approach is reach to people that you haven't reached so far. And then we have two main groups. So in terms of IT, currently, by the way, also according to Statista.com, is the number of women in IT is roughly about 17%.
17.
Yes, and it's been so actually for the last, since 2007 or so. You can see the graph, it's quite famous graph, by the way. That graphic is used in all kinds of conferences when we speak about women engineers and so on. The peak was in 84, and it was 37%.
So we were working with private in Bulgaria.
Pretty much everybody was working.
During this period.
Yeah, everybody was working with privates. It was called Apple IIe for the other engineers behind the other side of the iron curtain.
So actually, there were more women in 80s in workforce, like programmers in IT industry, than now.
Yes.
And now maybe the trend will be to go again up because
the obvious thing to do is to try to attract more women in the industry, because it's as I have often said, some of the greatest minds in IT are and were women. So like Margaret Hamilton, who was leading the MIT instrumentation lab and actually was the chief of the software development for the Apollo program, the whole Apollo program. Such as Grace Hopper, the first person basically to create a software compiler, and so on and so Ada Lovelace, the first developer at all. She was the first programmer, the first person to write code. But the problem is, during the 80s, personal computers became a thing, and they were marketed aggressively towards young boys and men. And what happened is that became adopted. There were a number of games. The games were tailored to be liked by young boys and so on. And basically, that and of course there are a number of other trends, but we don't have the time to discuss those. That basically led to the decline in women taking part in the industry, which is quite sad. And on the other hand, it's an opportunity because you have a lot of workforce that you can leverage potentially. The other trend is geography. Bulgaria has benefited from this a lot in the last 20 years, I believe. So it's basically find the educated people in new markets. So Bulgaria is not a huge talent pool, and what will happen in the next few years, as we were talking about the BRICS countries, you know, Brazil, Russia, and so on. Now people are talking about the mint countries. So Mexico, Indonesia, Nigeria, and Turkey. So they are relatively stable. They have educated people. They have a huge talent pool. They have mostly they have a huge pool of young people, educated young people. So if those countries decide to become the new IT hubs, they can very well do so.
You mentioned me about Africa, and actually we were talking before event about actually comparing Africa and Asia. I mean, India, everybody knows that in India there are a lot of, let's say, outsourced IT services. So what will be the trend? You said Africa and Mint is better than Asia because of...
Well,
what are, let's say...
As everything else in life, it's quite complicated, and I don't know all the variables, but two of the major ones are the time zones and the culture. So the time zones is basically most of the business, for better or worse, in information technology happens in the Western Hemisphere, on average. The problem with India is that it's a great talent pool. It's a huge country, quite a lot educated people, there is a joke that the number of genius level IQs in India is more than the population of Bulgaria. So it's a huge talent pool. But the problem is they're so far apart, the US and India, that they cannot work together effectively because one of the sides needs to do sacrifices in order to overlap at least
because of the time zones.
Exactly.
And the culture, you mentioned culture, it's because...
Yes, it's another thing that it's one thing to have a culture of execution and another to have a culture of basically analyzing the problem before trying to solve it. Because, and that's not problem actually only in India, the school systems and the education and academia in general usually produce problem solvers. They're focusing on producing problem solvers. The problem is nobody needs problem solvers anymore. We need problem definers. Usually the people don't know the root of the problem. They cannot distill it to a well-defined problem so they can solve it. Once you have a well-defined problem, everybody can solve it. The world is educated enough already to solve any kinds of problems if you know exactly what to do. And the problem with cultures is because you are the customer in Indian companies, they cannot say no or contradict you because your higher
mentality and culture
and
to say yes to everything.
Yes, you're like upper class, upper caste to them. So the problem is, hey, whatever you say, we agree. Whatever timelines you propose, we agree. Whatever solution you propose, we agree. The problem is they might be quite knowledgeable, actually more knowledgeable than you, and they can potentially propose better solutions to the problem that you pose. The problem is exactly if you propose something, they'll go with it because your word is the law. And that's one of the biggest assets that Bulgaria has as an IT engineering workforce.
Contradiction.
The first thing that the Bulgarian does when you tell them to do something is
it can't be done.
No, that can't be done, or
it can't be done.
Or if it could be done, it wouldn't be in that way. And that's actually a good thing because we try to think. We are not just
from different points. The solution.
You know the saying, tell a lazy person to do some work and they'll give you advice, and that's the thing about us. So we try to think on what we are doing and are we doing the right thing in the first place. So that's a good thing, and the general trend, as I was saying, is Bulgaria is just a small drop in the sea. We will not make any difference in the IT industry either way unless we come up with a genius level product or whatever. But even then, what usually happens is the situation with TikTok, for example. If you become too successful, you'll be forced basically by the...
to sell.
You'll be bought by some
Maybe
American
audience doesn't know, but TikTok is actually product of
it's a Chinese
product.
It's a Chinese startup.
And they've been forced to sell it to Oracle?
At the end they sold to Oracle, but they were pretty much given a notice to either cease their operations in the United States, which is one of their biggest markets, or basically receive an offer and be bought by an American company, which they did.
Actually, it comes to the thing that you said in advance, and it's the information. Who owns the information? He will be the king next, let's say, years. It's important who owns the information. It's like this.
Yes, and strategically speaking, the situation is stacked in favor of certain countries versus others, and those countries quite well understand the importance of information. That's why they want to control the world supply of information, which is, on one hand, it leads to better and faster digitalization, by the way, because when you have a number of companies that operate all the protocols, all the technology standards, it's much faster to implement such standards, because on the other hand you have monopoly, which is never a good thing for the end user like you and me. So it has benefits, it has some drawbacks and so on, but that's the trend. Also, as I said, automation. As you can see, automation in terms of as a market grows linearly in a linear fashion from year to year, and actually the growth, that line that sweeps down, is actually the year by year growth, which actually tells us that automation is actually slowing down. It used to be much faster accelerating. It's still accelerating, but to a much less degree. So automation will not solve the problem. It will only alleviate it to some extent, because through automation you cannot make new business. You can just improve the efficiency of the business you have. It's quite important, but the problem is there is constantly new market demands that are emerging, and it's quite hard to face those demands with ready plug-and-play solutions, if you will.
Actually, we've been talking before that with Croatia about low-code systems, because their platform is like this. So is it this the future, low-code? Because it's, let's say, give efficiency also to the one who owns the software, because he give, let's say, with drag and drop, and easily the user to do on his own what he wants as a product. I would prefer that if instead of to do it on my own easily, than to go to somebody, order something, waiting something. Is it the future?
Well, the future is so great that many things are part of the future. I don't want to sound like a Jesuit monk, but
you said automation,
definitely,
reusability.
Yes, definitely. Platforms such as low-code platforms are part of the future as well. Quite a few of the well-defined problems, actually, I believe in the near future there will be no demand for basically coding to resolve those, because they're well-understood problems, well-defined and actually well-solved. So such problems will be absolutely great for solving like problems such as, for example, logistics or well-defined problems.
And predicted. So it
healthcare, stuff that has been happening for years, everybody does it in the same way and so on. So, and it's well regulated. So they're great. They will also level the playing field, such platforms, for small companies will be able to have the automation that only big enterprises used to be able to access. So it will level the playing field. Small and medium-sized businesses, because of such platforms, will be able to digitize faster, but it will not be the whole future. It's too complicated, and because it's a system of chaos, it's hard to predict, because small changes in the initial conditions can lead to who knows what consequences.
And what about cloud? Because everybody, it's a tendency to everything to be in clouds, but it has maybe some issues about the cybersecurity, or we're talking about this, about who owns this information. It could happen, some fail, let's say, failure.
Failures are happening all the time. That's how we learn. So failures are a good thing.
But clouds give people, let's say, also very good possibilities.
Yes. They're, first of all, they were thought of as computing resources. Then they became business accelerators. For example, you don't have to train your anomaly detection models, for example, or whatever you want to do with AI. Most of the well-defined problems have already services in the cloud ready to just plug in and use. So the cloud is a natural progression, like people a few hundred years ago used to hold their savings under the mattress or something, and then banks were invented and money were centralized, which actually behind
now
the
you
security...
can pay by face, as Raiffeisen said previously, paid by face.
But the banks gave a lot more possibilities for businesses, even for financing big projects, than was previously thought. It's not just more security because armed guards are guarding your money or whatever. The current banks actually don't hold the money because they need to operate it all the time to make new money. But the idea is new possibilities will arise from the mass adoption that already happened with the cloud. The problem with cloud, there are a lot of problems, but the huge problem is like the reason that so many people died in the First World War is old tactics meet new technology. And what we see now is old ways of operating an enterprise are basically transferred to a different technology that has nothing to do with, there is no more a security perimeter. So back in the day, well, we are sending connection strings throughout the enterprise, whatever. All the systems are in a secured parameter. There is no such thing no more in the cloud unless you build one. And it's built in a different way. New skills are needed. So the problem is the cloud gives possibilities, but if you don't think in the right fashion about cloud, it's a potential security risk as well. So those are the current top security threats that are seen not only in the cloud but in general. And what happens actually is malware tend to decrease. Actually, there are less malware sites that try to inject malware, but phishing is increasing exponentially. And there are a lot of threats, and because one of the things that we eventually arrived at as a conclusion is regardless what you do in terms of software systems, you need to secure them. And that's why we came up eventually with our own cybersecurity risk manager solution, which is basically we try to encompass a number of things into one, because you cannot just monitor for network anomalies, you cannot just watch your cloud infrastructure, you cannot just, for example, monitor known threats in software libraries that you have used to build the software. Because we tend to think that, well, I'm using whatever version of whatever library, but that's a security liability because some other people wrote that code. People are not infallible. So those people that wrote the other code can pretty much introduce open source is a potential liability, as we saw with the Heartbleed bug. So somebody can maliciously insert security holes in open source projects for their personal gain, usually, but those holes can be exploited by whomever finds them, and it's quite frightening actually. So yeah, security, whatever we do, we live in a quite different world, and IoT is growing quite fast. Software, as you know, IoT is pretty much everything. You cannot turn on your washing machine or interact with your car or whatever. Regardless if you think you're a computer person or not, you cannot interact with the physical world without software being somewhere in the middle.
Actually, automotive is also something very, let's say, trendy in IT industry in the last 10 years maybe, or even. Because a few years ago, 2 years ago, it was on one masterclass with BMW, they told us that in next 5 years, cars will come alone. So automotive is something they work a lot, many companies on that, will come and take us from home. I mean, autopilot will be so smart.
Yes,
is it possible future in so, let's say, short terms of period,
No,
5 years?
That's the short answer.
No.
It's too optimistic, and it's optimistic not because that's. I'm of course a technology guy. I'm an engineer and so on. But looking at realistically at the world, if you will, moral issues. The legislation is too old for that. It changes in a much slower pace.
Who will blame if something happens?
For example, an automated car hits somebody and kills them. Is it the blame of the manufacturer, the owner of the car, the person that wrote the software, the person that tested the software, the person that approved the software? Who is to blame here? And what happens is, well, they all have some part of the blame, but nobody can be. So the current legislation cannot point to a guilty party in this regard. So the problem has nothing to do with technology. We have the technology for self-driving cars right now. We don't have the legislation. We don't have a lot of things that need to happen to be able to have free roaming automated cars. So technology-wise, yes, we can actually today we can have self-driving cars. The problem is not technology at all.
We have only one more minute. So do you have more to say about this?
Well, quite a lot, but if there are some questions, I would love to interact with the audience and answer if somebody is interested.
No, there are actually not questions, but I have one. You mentioned about the ethics in this for the coding. Is it also some kind of ethics? Exactly for this what we are talking about, this automotive especially, or now even when you go to hospital, it's proposed robotics surgery, and it's better and more precise than if.
What happens if a bug in that robot slices a person in half or whatever?
Nothing actually.
The problem is ethics has a huge topic. Part of the ethics has nothing to do with robots, actually. Is we gathered so much information. What is the legal limit and how do we maintain our privacy despite basically Facebook or Google knowing pretty much everything about us? So that's one part of the issue with ethics. Because we can only have assurances that our personal data is not used for malicious purposes. We cannot be entirely sure what that data is used for. After all, they are the data keepers. On the other hand, ethics is Martin Fowler, actually not Martin Fowler, but Robert Martin, has a lecture called the Scribe's Oath. So back in the day when most of the people were illiterate, the scribes, that were one of the few people, even the kings, most of them did not know how to write and read. So the laws were written, and the scribes had to take an oath that nothing that they write down, no decree, no law, will be changed by them, and they will write exactly as they were told. Because they could potentially set people free or change the law as it's written and so on. And right now, the IT community is in the position of the scribes. But there is no regulation, not even an oath. And we are and there is another ethical problem. Who holds the power? The person that passes the law, the person that writes the software system that actually implements the law. We had such an issue with our selection of judges. The system was written in such a way that you can have multiple selection of judges potentially and so on. So who is actually holding the power? The person that writes the laws or the person that actually does the software system that implements the laws? And it's quite ambiguous. And the IT community doesn't yet understand that they're holding that power. And once enough, but when something bad enough happens because of software, and enough people are injured, the outcry will be huge, And then the legislative powers will do what they do best. They will legislate and they will regulate the software industry. The problem is they don't understand pretty much anything about the software industry.
Just 1 minute and one question, very fast. Is there some changes in, the program languages? It's popular JavaScript, C++, Python. There are many. I'm not IT, but I know just few of them. PHP and whatever. And you mentioned previously that actually they were not changed in the past. I mean, like speed of writing or coding in the past 20, 30 years. So is it possible, because you said previously automation and reusage, is it possible artificial intelligence to be started to be used, or it's already maybe used for writing codes? I mean,
yes, it's being used, and it will be more so in the future, but languages will come and go. The concepts of how you develop code, there are only three types of imperative languages, only a handful of types of declarative languages that are used regardless. Most of the languages that are developed nowadays are imperative languages, where you tell the computer what to do on step-by-step basis, basically. But by the beginning of the 80s, pretty much 41 years ago, all the types of languages, so structured programming was there, object-oriented programming was there, functional programming was there. There's nothing new. Some languages are more type strict. Some other languages have exceptions. Other have objects, whatever. But the problem is not the language. The problem is the speed at which human beings process and resolve problems.
But then if artificial intelligence start to write codes, then the programmers will be in one moment useless.
Yes, but the problem is once artificial intelligence starts to write code, all people will become useless. Because
it's not a good part.
The problem is code can potentially solve a lot of problems.
Yeah.
All polynomial, and it's the P versus NP and so on. A lot of the problems that we face can be solved by software. That software must be written by humans because they are the problem solvers. Software is only the tool. In order for us to have artificial intelligence that can write any kind of software, it must be able to resolve any kind of problem, which means that it's a technology singularity. It's basically on human level at that point. What we have now is their code, and it's not sexy and so on, and that's why they don't call it that way, but it's called weak AI in the textbooks, which means you have an AI that can only solve a specific problem through a specific mean.
And nothing else.
Nothing else.
So humans won't be useless.
Hopefully.
Hopefully.
Because if we have artificial superintelligence, which is the next step, basically not only mimicking human level of intelligence and passing the Turing test, but the one step beyond, superintelligence.
Because we're talking
like
about
Skynet.
Better and beyond things. Thank you very much.
Thank you.
It's time for our next speaker. It was very interesting, and I hope that the ones that are not already online will write us or ask questions afterwards, because we'll send you also a record.
Thank you.